the constant S has been calculated and obtained 2 to the power 1 over P. Okay, and we also gave an example, but before that I have to introduce this notion. So we have a Banach space and P a cone with an empty interior. Okay, sorry, zone, and a partial ordering with respect to P. What is D? D is called the cone metric if these three axioms are satisfied, well-known axioms are satisfied. Then the pair XD is a cone metric space. Okay, and in the work of, together with my colleagues from Bapesba University, Andreea Molnar and Csaba Varga, which was published in 2011 on Ekelund's variational principle in B-metric spaces, we gave this example of a B-metric, and we consider a Banach E a Banach space, P a normal cone in E with a coefficient of normality denoted by K, and then this functional capital D, defined as the norm of the distances between X and Y, is where D is a cone metric. Then we can say that X together with capital D is a B-metric space with a constant S equals K. Okay. What can we say about Cauchy sequence convergent? If we work on a B-metric space XD, then we have the well-known notions of Cauchy sequence, of convergent sequence, which we will always use in the proofs of our theorems. Okay, also we have the notions of compact subset of a B-metric space, and also the notion of the closure of closed subset. Okay, the B-metric space is complete if every Cauchy sequence is convergent. What is actually the difference between the metric space and the B-metric space is the fact that in general the B-metric is not continuous. We have here this third assertion. The other are the same. A convergent sequence has a unique limit. Each convergent sequence is Cauchy. And what is also interesting is that the open ball in a B-metric space is not necessarily an open set, while the closed ball is not necessarily closed. And for the third assertion here, that the B-metric is not continuous, it has been proved this lemma that XD is B-metric space with a coefficient S, and we suppose that Xn and Xn and Yn are two convergent sequences respectively to X and Y, and then we have this inequality that 1 over S square times the distance between X and Y is less or equal than the infimum of the limit of distance xy, and less than or equal to the supremum limit, and it's less or equal than S square times the distances. Okay. We denoted by fixed F the fixed point set of F, and if we have this partial order relation on X, this denoted by less or equals in that sense, and we have a complete B-metric on X, then we can say this triple XD and the partial order relation is irregular. Then if for any increasing sequence Xn with this convergent to X star as n tends to infinity, we have that Xn is less or equal than X star for all natural numbers n. And we have that the triple is deregular if for any decreasing sequence Xn, which is convergent to X star, we have that Xn is greater or equal in this sense of the partial order relation than X star. Okay, now I present the fixed point results that we obtained in our case. First of all, we started from Ryan-Roering's theorem, and we generalized this theorem in the sense of the B-metric space, and also we changed the contraction condition. What says this theorem? we have a partially ordered set such that every pair xy has a lower bound and an upper bound. Furthermore, let D be a metric on X such XD is a complete metric space. So suppose F, the operator, is continuous and monotone, either increasing or decreasing, for which there exists a constant C, such that the condition is satisfied, this one condition. And yes, true. I can see here that there are two different numbers, okay, for these conditions. Let's say we take there from the left side. So the two conditions are satisfied. Then we say that f is a Picard operator. What's a Picard operator is actually an operator which has a unique fixed point, and the sequence of successive approximations converges to this fixed point x star. Okay, we present now the following generalization of the contraction principle given by Chirich. And that is, we have the metric space XD and f of mapping for which there exists a constant Q such that this condition is satisfied, this inequality. And if X as F is F orbitally complete, then we have the uniqueness of the fixed point, the convergence of the sequence of the successive approximations, as Fn of X converges to the fixed point, and we have also this estimation of the distance between Fn of X and the fixed point. Okay. For the proof of our result, it's an interesting result which was obtained also in B-metric spaces by Professor Miculescu, together with one of his PhD students. He proved some fixed point theorems for the case of multi-valued operators in the work, which is 5 here. I cited the references. And this lemma, which he used in his theorems, in the proof of his theorems, I also used for the proof of the main result. What says this lemma? That every sequence xn of elements from a B-metric space with constant S, having the property that there exists gamma between 0 and 1, such that this inequality is satisfied, is a Cauchy sequence. Okay. And we also have this estimation, and we used also the estimation in our result. Okay, and our main result is the following. We have a non-empty set, a partial order on X, and D a complete B metric on X with a constant S greater or equal than 1. Let F be an increasing mapping with respect to this partial order, for which there exists Q between 0 and 1 over S such that these three conditions are satisfied. First one is there exists X0 in X with X0 less or equal than F of X0 with respect to this partial order. F has closed graph with respect to D or the space XD, and this order relation is irregular. The Chirich, well-known Chirich contraction condition. Yeah, those elements which are comparable. Okay, and we obtain the existence of the fixed point. These conditions, we have just the existence of a fixed point. We have the sequence xn converges to the fixed point, which depends on x0. Okay, and we have the following estimation. Estimation, as I said, we obtained this estimation with the lemma of Professor Miculescu. Okay, if in addition this Q is less than S squared times 1 plus S, we also have the estimation between F of n and X star. And we have the sequence that converges to X star. What can we say about the uniqueness? So we obtain here just the existence of the fixed point. And about the uniqueness of the fixed point, we have to pose this condition. So if we suppose that for every pair x, y of the elements which are not comparable with respect to less or equal, there exists set such that this set is comparable with x and y. Then we obtain the uniqueness of the fixed point, and the sequence Fn converges to the x star, the fixed point. Okay, a similar result holds if we replace this condition with the f of x0 is less or equal than x0, and the irregularity of the space with its irregularity. We also proved an Ulam-Haier stability result for the fixed point equation, and in a few words what's actually Ulam-Haier stability about. So if we have a B-metric space and an operator f, the fixed point equation is Ulam-Haier stable if there exists a constant c such for any approximate solution. The approximate solution is that a solution y star which satisfies the inequality number 5. There exists an exact solution x star such that the distance between the approximate solution and the fixed exact solution is less or equal than c times epsilon, which is greater than 0 epsilon. Okay, so this is the Ulam-Haier stability. And concerning this Ulam-Haier stability, we have some partial answer in our Chirich case. We consider that Xn is a non-empty set, less or equal is a partial order on X, and D a B-metric on X. F is a prism mapping. We have that Q is between 0 and 1 over S squared times 1 plus S. These three conditions are satisfied. These are actually the same conditions that appeared in the theorem, the main theorem, which we proved. Then we have the fixed point, this is the fixed point that we had this. And the fixed point equation has the following Ulam-Haier type stability. There exists C for that, such that for each epsilon and each approximate solution which is comparable to x0 and satisfies this inequality, there exists an exact solution of the equation such that there is a distance between y and x is less or equal than c times epsilon. Okay, we have here a well-posed result that we in the theorem 14 we have a non-empty set, a full order, and a complete B-metric on X. And to suppose that all the hypotheses of the previous theorem hold, that main theorem, then we have a unique point. And if xn is a sequence in X such that the distance between xn and f of xn tends to 0, as n tends to infinity, then xn tends to x star. So we can also say that, in other words, that the fixed equation for is well posed. We also have a data dependence result, and concerning this, we can prove this theorem. So we also are in hypothesis of the theorem 11 with the constant q is less than 2 over s times s plus 1. If we have, so we consider the operator f, with a fixed point, and we have g, another operator, such that there exists eta with the distance between the images of the x through f and g is less or equal than eta, then if g has a fixed point, then the distance between the fixed point of g and the fixed point of f is less or equal than this constant times eta. You can estimate the following estimation. Okay, as an application, we considered this coupled fixed point problem. If X is a non-empty set and F, capital F, is a given operator, find a pair X, Y satisfying this system 7. An important related problem is to find the strong fixed points of V, that is the elements with the property that x is equals f of x, f x. That the f of x, x is also called the diagonal operator. And by our main result, we have the following couple fixed point theorem for Chirich type operators. That is, we work on a non-empty set, the partial order on X and be a complete B metric at F. F is a mixed monotone operator, increasing in the first variable and decreasing in the second one. That's a mixed monotone operator, such that F has a closed graph or the triple is irregular. There exists a couple x0, y0 such that these two inequalities hold. There exists Q between 0 and 1 over S such that this inequality holds, this Chirich inequality holds actually. Then F had at least one couple fixed point, x star, y star. The sequences Fn of x0, y0 and Fn of y0, x0 converges to x star and to y star respectively. If the elements x star, y star are comparable with respect to this partial relation, then x star is equals y star. So we have x star a strong fixed point for F. And in addition, if in addition Q is less than 1 over S squared times 1 plus S, and we suppose that we have these inequalities for the couples here, then the couple fixed point is unique and the sequences converges to x star and to y star. Okay. For the couple fixed point problem, several collective properties such as data dependence, Euler-Meyer stability, well-posedness can be also obtained from the corresponding fixed point results. For the references, I talked about the work of Bakhtin, Berinde, Chirich, Chervik, and as I said, the work of Miculescu and Mihail was used in our main result and other results that we used. Thank you for your attention.
Yeah, Dr. Davamani. Christopher.
Principal is in another meeting, sir.
Is another
Shall we
meeting.
continue?
So
Sir?
I would like to request Professor Ermal Thiwagar, sir, to say a few words about the presentation of Dr. Monica. Please unmute Dr. Thiwagar.
Lily, sir.
Yeah, please unmute Dr. Thiwagar.
Lily, sir, you please unmute yourself, sir.
Okay.
Yeah.
Yes, sir.
Please.
Sir, just now only I come into the picture. Please ask Professor Neela Anbalagan.
Yeah, Professor Monica just presented her talk, and Dr. Davamani was the chairperson. He is, I think, busy in another meeting. Say a few words about the mathematical contribution of Dr. Monica. Otherwise, I may ask.
Better do you continue, sir? You please.
Okay. Dr. Monica, it is a first experience. You have first time visited India. First time you have been invited to FAI International Conference. And
yes,
wonderful mathematical output that you have developed in the field of fixed point theory. Yesterday, Dr. Monica, Dr. Liliana asked a question that why this issue, once it is resolved as a fixed, why the numerical number 0 is considered there?
Yes, it's a good question. I saw her presentation and it was
okay.
yes.
So regarding the fixed point theorem and 0 is a question, why 0 is being decided as a decision maker that the issue has been fixed. So all of you should develop something to resolve this issue, because you are the fellows of fellow mathematicians of fixed point theory. Here in Madhya Pradesh, here one of the state in India, there are very good number who are there are good number of workers who are working in the field of fixed point theory. Good workers are here. So on behalf of the chairperson, Mr. Dr. Dawamani, because he is busy in a meeting, as he is the chief patron of this this conference, I would like to give thanks for your nice presentation.
Thank you.
And
Thank you very
hope
much.
in future you will join us once again.
Yes, thank you for your invitation. With pleasure.
Sure. Yes. So next time, definitely you will be with us for sharing your knowledge and inspiring the young researchers, those who are starting or learning or doing something to improve their work. Your valuable suggestion will be helpful to all of them. Thanks, Dr. Monica.
Thank you very much. Thank you.
Dr. Liliana, would you like to say something?
Yes, concerning our zero. In mathematics, when something goes to zero, then we work for nothing.
Because here another mathematician from Romania, Dr. Georgia, is also available. I would like to invite Georgia to say a few words about your fellow colleague. Please unmute, Dr. Georgia.
Okay, thank you. I wasn't able to unmute before.
Okay.
Hello again, everybody. I am very happy to be here today also with you. Everything is very nice and interesting, and I'm just getting used to the idea of being in touch with everybody, being morning, afternoon, evening, different time zones. It's so great for me. I have to confess, I don't know much about the subject Liliana and Monica are talking about, but I have I do remember the problem with the zero, and yes, well, sometimes it's frustrating to do all that computations and in the end you get zero. Oh well, but that's just life. Sometimes you get a positive answer, other times just a zero. Okay, so. Good luck, and hoping that that zero you obtain is a positive one, and a zero that will lead to more important discoveries in the future.
Future regarding the fixed point and the decision-making theory.
Yes. Thank you so much.
Yeah, thanks, Dr. Georgia. Thanks once again that you joined once again.
Thank you.
Yes. So now I request Dr. Amuta to proceed for the next session.
Yes, sir. Yes. Thank you, Professor. Now I request Professor Anbalagan, Department of Mathematics, Alagappa University, Karaikudi, to chair the session.
Unmute.
He is a professor and head Department of Mathematics, Alagappa University. Please mention.
Yeah.
Okay, sir. Okay.
Anbalagan is a professor. Yeah, professor.
I think very strict administrators are here. Very strict administrator. We are all continuously requesting them. Please unmute.
Yes, Professor.
Let me, Dr. Anbalagan,
by host. Yeah, it is muted by host. So
muted by the host.
Yeah.
Professor Anbalagan is a professor and head of the Department of Mathematics and Ramanujan Institute of Higher Education, Alagappa University. He is the convener of this conference as well, along with me, Professor Lilis Divagar and Dr. Muge Sakar. So I think Professor Anbalagan, please, the fellow speaker is a very good friend of our circle.
Yeah.
Professor Pankaj Mathur. Both are the symbol of the lotus.
Yeah. So good afternoon to one and all. So once again, I welcome all the delegates for this second day conference. I am happy to introduce Professor Pankaj Mathur. He is working as a professor in the Department of Mathematics and Astronomy in Lucknow University, Lucknow, from 4th August 2011. And he received many awards, many prestigious awards. In one of the prestigious awards is he received a Boy Scout Fellowship. This is a fellowship for given doing a postdoctoral fellowship. I think he went to Vanderbilt University, USA, in the duration 2007 to 2008. And he received a Young Scientist Award from Indian Science Congress Association in Lucknow in the year 2001. And also he received a Best Paper Award from the 66th Conference of Indian Mathematical Society, which is held at Aurangabad in the year 2000. Then he also received another paper, Best Paper Award in the another conference. And also he has more than 48 research papers published in the various reputed refereed journals, international level journals. He's 4 students are completed their PhDs under his able guidance, and 3 are doing their PhD. And he is having one ongoing project. So with this introduction, I invite Professor Pankaj Mathur to deliver the invited talk. Please, sir.
Oh, thank you very much, Professor Saab. First of all, I'm thankful to Professor Pankaj Srivastava, very good friend, colleague, guide, and mentor, whatever you can say about him. So I'm very much thankful to him to give me this opportunity to talk to a galaxy of, great mathematicians. I was hearing something about zero, but we are really loving to have a zero at some place. that is what I am going to talk about, the COVID-19 effect. So we want to see a zero over there. So that is a fixed point, and that may help us out somehow. I don't know, but still, should I share my screen? Okay. I hope I'm able to share the screen now. Is it visible? Yeah. So I hope the screen would be visible to all the fellow members.
Yes.
Great. So once again, thank you very much, Professor. Okay, so thank you very much. The talk of my that I have chosen to speak on, although it's not my subject, but it's very fascinating to build a mathematical model that can turn a physical problem to mathematics, and somehow you can judge what is going to happen in some sense. And because of the global nature of mathematics, it is able to give an idea about what may happen by testing the things locally, what may happen globally. Definitely under certain conditions, mathematics is always there to help you out in that case. So the title of my talk is The Effectiveness of the Lockdown to Curtail the Spread of Coronavirus, a Mathematical Model. And you may say it's a case study in India. So I very quickly go on to what the coronavirus is. All of us are very much aware of it now. So it's an infectious disease and very new. and it transmits through coughing, sneezing, or exhaling. And it's the droplets which come out due to coughs and sneezes are quite heavy, so they do not hang on the air and they fall down on the surface. And if anybody who is in very close proximity to those who are infected with this virus are very much in danger, and they may also get infected if they come in contact with the contaminated surface as well. Now they may have some mild, moderate, and sometimes no symptoms. The situation is so damn dangerous that a lot of people have succumbed to this disease, and still it's going on on a very high rate. Although the recovery rate in India at least has increased a lot. Yeah, so even though there is no specific treatments for the disease caused by the virus, the doctors, the nurses, and the paramedical staff had put a lot of effort to cure and save the lives of the infected patients all over the world. And as such, they are most vulnerable of getting infected. But still, by wearing taking some precautionary measures, that is by wearing some PPE kits, masks, gloves, and taking care, they avoid of getting infected. Even though there are medical staff, there are medical persons who got infected and were sometimes that disease was fatal for them. So there were many changes done by WHO. Initially, it was like persons with the higher age were getting infected, but it turned out that anybody can be even a child with 10 years of age or less can even be infected with coronavirus. So all the time it get changed, and ultimately it was that a person of any age group can get infected from coronavirus. So when you have no remedy of or you do not have any medical treatment for certain ailment, then the only way of getting through this pandemic was to somehow contain the spread of COVID-19, although that was a very tough task, because the cycle of that virus is like 14 to 28 days. It was varying between the two, and at sometimes it was very a high load of virus was seen, and sometimes it was a very people got affected, but were there were no symptoms. They got without any medication, they got themselves accurate. As the symptoms of the infection appears very late, it is not possible for anyone to identify if a person to whom he is meeting is COVID-19 positive or not. So it spreads because this viral infection disease spreads through transmission. Its spread may be contained by improving the immunity of the susceptible population. Using proper susceptible, I will be defining it in my next slide. Using proper kits like masks, PPE kits, and gloves. But everybody has to. The economics was very much disturbed due to this virus. As soon as the governments implemented the lockdowns, the general public were nowhere, but they had to earn their earnings. So they had to go out, and once you are out, you are either a carrier or you are vulnerable, whether you are getting infected or not. To reduce the spread of the disease, government of many countries took a very hard decision to lock down their countries. even though the lockdown is not an easy step for any government, as it serves a major disruption of the economy. But still, no nation was in the position to take the risk of allow the epidemic to spread and then treating a huge number of patients. The information regarding the possible ways of protection against the disease was propagated through TV, radio, social media, etc. As a result, some of the aware people use precautionary measures for their for their protection, but only a few. So, what motivated me to do this sort of research? There are a lot of papers you can find on COVID-19. A lot of mathematical models are there, but mostly what they have considered is that the infected population is interacting with the susceptible population, and that was assumed to be a major cause of disease. But as far as I understand, this disease does not only spread through direct contact with the susceptible to the infected individuals, whereas these infected individuals also act as carriers of the virus and may spread this disease. As such, we have assumed that the disease spreads among the susceptible individuals through transmission of virus that is present not only in the infected individuals, but also in the environment. That is what we have considered a mathematical model that deals with the importance of the lockdown in controlling and maintaining the spread of COVID-19 virus. We have also considered the impact of the virus on the susceptible population instead of the interaction of the as I already have mentioned. This all helps in herd transmission, which is the case with the COVID-19 case. We have also taken into account the fact it's our model population, infective population, and the recovered population. We are the virus which is present in the infected person at any time already informed. Okay, so these are the parameters which I am considering. So I am taking that the susceptible class. What I am taking is as the immigrated peoples, people coming from outside the country or moving from one state to the other state or one city to another city. So, and mu is the rate at which the immigrated population in the susceptible class becomes infected. Beta is the rate at which a person in susceptible class moves to the infected class. NP is the rate at which the susceptible class protects from moving. So I must go for this thing. So this describes my. So S is the susceptible class of population, I is the infected class of population, and R is the recovered class of population. So I am saying that mu is the rate. Mu is the immigrant population in the susceptible class affected. So if A as the number of population, then the infected population. So it is going directly to infected, and what is left is So they are going from I to S, and this beta is the rate at which the susceptible class are getting infected. So, and NP is the rate at which the susceptible class are protecting themselves from getting infected. So 1 minus NP are not protecting themselves, and they are more vulnerable of getting infected. And with beta rate, they are moving to infected class. And one more term I have added is AS. So it becomes something like beta 1 minus NP times AS square. So what is happening is these fellows are moving with the susceptible class, and what they are doing is they are increasing the rate at which these susceptible persons are getting infected by the virus. So this is what plays a major role in getting susceptible persons to be infected. Gamma is the recovery rate. Delta is the rate at which is the natural death rate. It is for all the three cases. That is for susceptible class, the infected class, as well as the recovered class. And alpha is the death rate of the infected people infected due to this coronavirus, COVID-19. They are getting this is the death rate of the infected persons from coronavirus. Okay, so this is the dynamics of V, that is the virus. So it is increasing at C1 is the rate. AC1 is the rate due to which the infected persons are the virus is increasing due to the infected persons, and it is decaying because we many times say that the cycle of a coronavirus is 14 to 28 days. So it is decaying by itself with the rate C3, and so this is our model, and it has been written in the form of differential equations, the system of differential equations. This okay. And we have taken the solutions at the initial point to be positive. That means that the system exists. So these are the solution of the model with initial condition are positive. And this is the region where this is the region where the solution of the model exists. So question marks are because I don't know, I have run the text file only once, so that gives us the question marks. Okay, so basic reproduction number. So this is a very important term in the case of disease studies, infectious disease, when we are modeling the infectious disease. So what we want as a mathematician and as the medical practitioners is to reduce the infections. And R0 is the term which let you know about that part. So if R0 is less than 1, then we say that the spread of the disease is controlled. It is not spreading. And if by any chance it is bigger than 1, then the spread is higher the number R0 is. The greater is the spread of the virus. So what we always want is to get this R0 to be less than 1. So it is R0, not 0. So in our case, the reproduction number turns out to be this, and if I have given a particular example, special case by taking gamma as 0. Gamma is the recovery rate. Gamma is the recovery rate, as already told. So it is coming in the denominator. So if our gamma is 0 and at gamma equal to 0, I call R0 as R01, then R01 is much higher than R0. So higher as the recovery rate increases, higher is the recovery rate, R0 will get lower and lower. Okay, so these are the equilibrium points. This is some mathematics, I'm not going into it. So these are all stability, these equilibrium analysis. Now, good. So this is what we are looking at. So it is as a mathematicians, we are always looking to construct a model and do a whole lot of mathematics. But the mathematics is only fruitful if it can say something about the problem as it can say something about solving the physical problem. So it can only be done through examples. So what we are doing is a numerical computation. So these are the parameters which are being involved in our model, and we have estimated these parameters with the help of least squares approximation, best fit. And by taking these parameters, we have considered 5 different cases, and we have shown in this paper that these 4 quantities are the most, in fact, these 3 quantities are the most effective parameters regarding the which affects the basic reproduction number. So by changing, by keeping all other parameters fixed, we change these to a lot of numbers, and we arrived at these 5 situations. As an example, we have given them. So if you see here, the R0 is becoming less than 1. It is getting decreased all the times. So by reducing A and reducing NP, and beta is it is almost fixed for all the in all the cases. But if our A is decreased, A is the rate at which the infected population is moving with the susceptible population without knowing either they are asymptomatic, or if they are symptomatic, they are hiding that and moving with the susceptible population. So, and that is what our lockdown will affect. If we are putting a complete lockdown, that means if I say A is 0, that is I'm not allowing any citizen to move freely. So if this becomes 0, then R0 will be very less. That means the spread of the virus will be very much in control. So these are the explanations. So Professor Srivastava, how much time do I have with me?
20 minutes is assigned to you total.
And how much time is left?
I think 5 minutes.
So okay, thank you. I just go very quickly. So these are examples we have seen. So I just go on to the figures. So I said in the beginning that I would be dealing with the Indian data. So to check the feasibility of our model, we have taken actual data of India from ICMR, that is the Indian Council of Medical Research, and the WHO. And we have taken data of 68 days, that is from 25th March 2020 to 31st March 2020. And we have taken as we are taking the cases from India. So in India, there are 4 phases of lockdown being removed. The first lockdown was for 21 days from 25th March to 14th April. The second was from 15th April to 3rd May of 19 days. The third was from 4th May to 17th May. It was of 14 days. And fourth was from 18th May 2020 to 31st May 2020, again for 14 days. So what happened during these lockdown was, see, the number of days are from 25th March to 18th of March, and these are the number of reported infected cases. So blue line is the actual case, and red line is the one obtained from our model. So you see there is a very close proximity between the two, and the number of infected persons is also very low, not a lot. So now we go to the second one. It is between 15 April to 6th May. So it is the 19th day curve, and again the proximity between the two curves is quite low. The same is with the third one. This is the third phase from 4th May 2020 to 17th May 2020. And this is from 18th May to 2nd of June. In fact, 2nd of June, you can say. So this is your total graph. This is the graph of the 68 days between 25th March to 3rd of June. So this is, as you can very well see, that our model is also predicting the number of cases in India, and they are quite close to what they actually were on these days, during these days. So this is the effect of beta, this is NP, and this is. So conclusions. So I do not go for this one, I go for this. This is a good graph. People living in India would be very much interested in seeing this bell, because this graph says about because our model was predicting quite closely the number of infected cases during 68 days. So taking that into effect, we plotted a graph about in how many days would this coronavirus may end. So by our assumption, the maximum number is going to be this much, that is 1 into 10 to the power 7, that is approximately 1 crores. So it is above that. So maybe something around 1.2 or 1.3, I don't know. And the number of days it is taking is 400 days to reach this peak, and 800 days when this slides down to 0 automatically without any medication. So it is sliding down after 400 days. I think it is hidden in this below blue line. So 800 days means something like, let me check it out. So it is like 2 years it will take to get down to this stage. It is approximately 2 years, maybe more by itself. But if some sort of a medication or something else is there with us, then it may come down at much earlier, and that is what we want. So these are the references. So these are my references. Thank you very much, sir, for your time which you gave me to present my work. Thank you.
Thank you.
Professor
Thank you, Professor. Thank you for your nice talk. Professor, is it possible to the complete lockdown in like India or some low income countries? Is it possible the complete lockdown is?
No, it is not.
How much days you need? for complete lockdown?
So it is not easy to put a complete lockdown. The economy of a country is definitely going to be affected as soon as you put a complete lockdown.
Definitely.
So if you go in the economics, I have heard a few lectures where they say that a partial lockdown, starting with a partial lockdown and going for and increasing it accordingly, and if needed, like in like these days, what is happening in Britain and all. So accordingly, you can go for a full lockdown if the need arises. But it's a tough decision. I mean, it hurts a lot.
So
you are right.
your A is some positive level, not zero, not possible.
Yeah, you have to be.
Yes, Professor. So anyway, thank you for your nice talk about controlling and maintaining the spread of COVID virus in the lockdown time. Definitely, it is a self-control in each and everyone. So otherwise, we could reduce the spread. So thank you, Professor, once again. Thank you for your nice talk.
Thanks, Professor Neil Albargan and Professor Pankaj Mathur. Thanks for their contribution. Spared time from your busy schedule and contributed something for the society. And I am happy to see that the last year host, Professor S.S. Thakur, is here.
Yeah.
So, Professor Neil Albargan, Professor Diwakar, are you here?
Yeah, Professor Thakur is here.
Yeah.
We
so
are
welcome,
Jabalpur.
Professor S.S. Thakur.
Professor, good evening. Thakur, Professor, good evening.
Yeah, Amutha, please unmute the mic of Professor S.S. Thakur. Amutha.
So we met in Jabalpur.
Yes, sir.
Very tough administrator. Very tough administrator. Every time we'll have to make a request. Please unmute Professor Thakur.
We met
Professor
in
S.S. Thakur.
Jabalpur, Professor.
Yeah, Jabalpur.
Yeah, Jabalpur.
Yes, we did, sir.
Yeah. Professor Thakur, you have joined the program. I think tomorrow you will have to deliver a talk.
So you unmute your mic now, Professor. Thakur, sir, you unmute your mic now. Otherwise, the host will now open all the mics. That is one by one. You should not.
Host.
Yeah, now it's okay.
Yes, sir. So, my fellow colleagues, I would like to introduce Professor S.S. Thakur. Last year, 2019 ICMCIE. That conference was organized by Professor S.S. Thakur on the occasion of the Diamond Jubilee celebration of the Jabalpur Engineering College. And myself, Professor Diwakar, and all the fellow colleagues were there. And this program was also organized in collaboration with the FAI. Professor Thakur, I would like to request you to say a few words.
First of all, I congratulate for this FAI for this successful conference, and I am also thankful for the FAI for the publishing proceeding. I think proceeding is ready for last conference. Especially I congratulate Professor Srivastava for their efforts for the publishing this proceeding of ICMCIE 19 with Springer.
Yes. So thank you, sir.
Thank you, sir.
Thank you, sir.
I will deliver a talk on tomorrow.
Yeah, yes, sir. Sure. So,
paper presentation.
Yeah, organizers, Dr. Amutha. Dr. Amutha. So I would like to request Professor C.C. Tan. Professor Tan, are you here?
Yes, sir.
Yes, he is here.
Professor Tan is here. Professor Tan is here.
Tan.
Unmute
பண்ணி விடுங்கம்மா. CC Tan.
So CC Tan is here.
Unmute. Madam, you unmute
Yes,
all
we did it, sir.
all the.
We did it, sir.
Yeah, now you, Professor
Okay.
Tan. Okay.
Yeah,
Professor Tan.
Yes, I'm so happy to see so many colleagues, mathematicians. Your brains are very powerful. I used to study and love mathematics, and in the past, and do a lot of computation and mathematics, but it totally disappeared. And when I see you guys, it's very wonderful. Yeah, it's really very your brain is very wonderful. It's a super brain. So congratulations and thank you very much, and thank you for teaching me the wonders of mathematics, and let me refocus again on the reiterate at least on the minimum part on the the need for mathematics, yeah, but not on your side. Yeah, thank you.
Okay, Professor Tan, actually I asked you that just now the talk delivered by Professor Pankaj Mathur.
Yeah.
And one query was asked by Professor Neil Albargan, whether the complete lockdown is feasible. What is your view? Because you are a management fellow.
Yeah.
And I think Professor Nina is not here, or Professor Zanaida is not here. If they are here, so definitely they should come forward because they are professor of economics. So this is the issue of, yeah.
Yeah, well, from the management perspective, well, we the key thing it's about the social psychologicals and motivations or the needs, the livelihood needs issue. So if we can resolve all these priorities and ensure that things are happening and on an equal ethical basis, fair basis, that should be okay. So there are, mathematics, if we can look into those ethical perspective, motivation perspective, and also the maybe compensating the businesses, then okay. Otherwise, it's very difficult for complete lockdown. And again, complete lockdown, has to be policy driven, is really effective, because I brought my students to for a field trip, which I will discuss tomorrow. And I feel that if we don't have a policy coming from the top down, like a lockdown, it is impossible. It is very impossible for us to wash the hand, for us to, clean with the, be careful on every journey. And so lockdown is 100% for sure. But again, we have to do in a way that social, psychological, and commercial and ethical, the holistic understanding. Yeah. Otherwise, it's very difficult. Yeah.
Okay. Okay, this is the view of a management fellow. So let me ask the mathematicians. I would like to ask Georgia Oroz to share their views, share her views about the question raised by Professor Neil Albargan regarding a mathematical model. Absolute lockdown is feasible. Mathematically, it is feasible, no doubt about it. Physically, it is okay.
Well, I really don't know what to say about all this pandemic situation. First of all, I think complete lockdowns are not possible without having very bad side effects, not for the health of the people, but for their lifestyle and of course for the economy of each country. I think lockdown is really not a solution because it's very, the side effects are more and worse than the disease itself. On the other hand, I believe that everything that involves biology and the phenomena of nature cannot be very well predicted. Often there appear variables that you cannot even imagine that exist. So the mathematical models are great. I think they have some they can make an image on how it could happen, but I don't believe that they are very accurate, because all the variables you cannot take into considerations, and the variables are way too much, too many variables, and the unexpected can happen at any point, because we are talking about biology here. It's not something we can put into very well patterns, very good patterns, because we cannot predict. But the mathematical model saying that this pandemic will end in 2 years' time if nothing is done from the medical point of view, I believe it to be correct, because as we know, the last pandemic, the very big pandemic known, took 2 years to end. So I believe this is possible to be the case here too. Of course, I hope this will not happen like that. I hope that this time mathematics is wrong. But again, usually mathematics is right. So all we can do is hope.
Yes.
So no, I don't believe that a complete lockdown is possible anyway.
Yeah.
And I believe that we will have to face it. And I have also another view on this matter. I believe that only those who are meant to disappear during this pandemic will disappear, but the rest, we will be okay. We will pass through it, and like every other important pandemics in the history of humanity, it will pass, and those who need to disappear will disappear, and those who will be lucky enough, or maybe not lucky, worthy enough, will be passing this pandemic.
Yes,
so I don't know what else to say. I do trust mathematics, but I know that sometimes it cannot be the answer to everything.
Yes.
Because not always we can take into consideration all the variables.
Yes.
And this biology stuff is very unpredictable.
Yeah. That's why medical persons always believe on God. They say that something that is not going to happen, and something unexpected is going to be predicted as a unexpected results are always happens in medical science.
Yes, and we can also have bad surprises, but we must hope that good surprises will arrive, and that we will be guided into getting out of this pandemic sooner than we thought possible. Because anything is possible. That's what I strongly believe.
Sure. Thanks, Dr. Georgia.
Thank you.
Adding your philosophical input, biological input, and sound basis of mathematical inputs. Thank you. So may I ask here, Professor Ali is here? Professor Ali? Professor Liliana? Okay, no problem. So now I request Professor B.S. Bisser to say a few words. And before that, a very beautiful lecture was delivered by Professor Elizabeth from Portugal. And that lecture is recorded and it is available on the YouTube. If you type IUBGMS 2020, and this was happened on November 21. The lecture delivered under the FAI International Conference that was organized with 6 universities from abroad during the November 22. Very decent, very interesting lecture was delivered by Professor Elizabeth. A very clear-cut pattern she depicted since the 17th century, and said some quoted remarks. It is better that if you visit that site, YouTube, and search this IUBGMS 2020 and listen that lecture. that what she quoted actually looks like that, because the vaccine that has been designed or developed so far, accuracy is not 100%. Negative effects are still to be tested, or it is to be taken care, because in a very short notice this vaccine is designed. She says that now we will have to live with a discipline, forget the ways of living that we during the past years we lived. We will have to live with safe and precautionary measures to be protected by this unexpected output of this COVID-19 virus. Nobody knows. The trend has been observed that the COVID-19 almost destroyed the iron saturation domain in the body system, because that's why the patients, those who are suffered by this disease, are having a strong weakness. That is because the iron saturation level is almost destroyed by the COVID-19. So recovery 2 years, that's fine, but the weakness and the human physiology to be investigated once again. So now I invite Professor B.S. Bissar to say a few words, and then Professor Dr. Meenakshi to share the remarks of the today's invited talks, followed by the 6 parallel sessions where the number of papers to be presented in the respective Zoom rooms that will be instructed by our Amuta. So Professor B.S. Bissar, say a few words about. Please unmute, distinguished administrative body. Please unmute Professor B.S. Bissar. Please unmute. Dr. Amutha, please unmute Professor B.S. Bissar.
Sir, done, sir. We did it, sir.
Yes, sir. Bissar, unmute yourself. Please unmute. B.S. Bissar is still unmuted.
Yeah. Am I audible now?
Yeah, audible, sir, audible.
Thank you. Thank you for giving this opportunity. I'll take a minute. First, I'd like to speak about the mathematical model that has been presented by the learned scientist from Lucknow University. Appreciated. And this effort could have been done by us, by more number of scientists, because that will give us kind of idea as to how the model has been behaving with respect to the reality and what measures are to be taken. I would like to add that in social and biological systems, there is no 0 and there is no 1. So between 0 and 1, there are the limits wherein we have to play. For example, a complete lockdown could be a situation of one complete lockdown, and 0 could be a situation where there is no lockdown at all and no restriction at all. But it cannot be 1 or 0 always. So if it is 1 and 0, the system will behave erratically and then will not come to any conclusion at all. As has been pointed out, that in biological systems, it is not possible to have complete lockdown. If there is complete lockdown, theoretically, mathematically, then it will lead to several other problems in the society. And the system will resonate. And resonance of the system means destruction of the system at many points. And now about the model. Maybe that large number of variables have been taken care, but then it has become very sensitive. If there are less number of variables, for example, J.W. Forrester, when he tried to model the world economy versus the quality of life versus the industrial growth, then he realized that the robust systems behave much better because the biological systems are robust. They are not highly sensitive, but they are to some degree robust systems. In case of robust systems, it is possible to have lesser number of variables and then model these and validate. Validation is extremely important. As far as my assessment goes, it will be possible to have vaccine very soon, and thereby along with the other measures in the society, including the social distancing and then mask and then PPE kits and so on and so forth, plus some other herbal kind of treatments and other treatments, it should be possible to cure the disease earlier than 2 years, earlier than that. So this is my assessment as far as the situation is concerned, but I appreciate the effort of the scientists that they have tried to, that he has tried to model the situation. Probably it will help in future for such kind of situations arising. Overall, I find that good rigor has been provided and given as far as mathematics is concerned. I appreciate the faculty, the professors for discussing those presenting over here. About zero, again, a lot of interesting discussion took place. And zero, we know that was invented a few centuries back, either in India or in other parts of the world. And it was very interesting. In totality, I must say that the sessions have been going very well. And I congratulate Dr. Pankaj and Dr. Amutha and other friends from American College. Thank you very much.
Thanks, sir. Thanks. Now, Dr. Amutha. Dr. Amutha.
Yes, sir.
Yeah, now you make the announcement. Dear colleagues, this is a 6th parallel session as today is going to be conducted for the paper presentation session. And there are 6 parallel chambers will be created. Each chamber will be taken care by the respective chairperson and with an assignment to judge the best presentation of their own section and submit that details to the Dr. Amutha. As we have already announced that the best presenter will be honored during the next conference that is likely to be scheduled in the month of February 2021. Dr. Amutha, now please go ahead.
Yes, sir. First, I would like to thank all the dignitaries who have shared their valuable knowledge with us. Really, we are enjoyed and it is a thought-provoking session. I hope all the researchers would benefited. Now, the announcement to the participants. Dear participants and presenters, there is an announcement from the organizing committee. Day 1 and day 2 paper presentations details schedule are updated in website. Also, we sent to your mail. Check your mail and website. Participants, please join in the given link. Today, there are 6 sessions. After the keynote speech, we'll start the session. The single window or the screen will be divided into breakout 6 windows. In your system or mobile, you can find a new icon of 4 boxes. Click the icon. It shows session 1, session 2, session 3, session 4, session 5, and session 6. Presenters can join your respective session. Participants or listeners can join any session. If you face any difficulties, then don't panic or worry. We are here to help you. Just ping your difficulties in the chat box with the name and ID, or call the number 9840858539 or 999481065. Sorry,
I think
99948
mention the number in the chat box.
106. Yes, we will mention it.
Mention
Dear participants, presentation is mandatory. The chairperson and moderators' comments and a grade or rank will be taken into the account of the reviewer of Springer journal comments.
Madam, please
And,
ensure all the chairpersons are available or not. Please ensure.
Yes, yes, sir. Yes, sir. Yes. And a pleasant news to you from the conveners: a good presenter will be evaluating by the chairperson, and he or she may be honored in the next Factor Academy of India conference. And we in two slots, so we are having the converted us in 6 sessions. It is of the all the it is 2 slots. Now we have parallel sessions, and we have 6 chairpersons. Dr. Meenakshi Srivastava.
Yeah, one by one, please call. Yeah.
Assistant Professor, Amity Institute of Information Technology, Amity University, Lucknow, India. And in second session, we have Dr. Sunil Dutt Purohit, Secretary for Rajasthan Chapter, Associate Professor of Mathematics, Department of Mathematics, and Rajasthan Technical University, Kota, India. And in third session, we have Dr. S. Samuda, Assistant Professor, Ramanujan Center for Higher Mathematics, Alakappa University, Karaikudi, India. In fourth session, Dr. Prajesh Kumar Jha, Secretary, FAI, Gujarat Chapter, Assistant Professor Max, School of Technology, Pandit Deen Dayal Petroleum University, Raisin Village, Gandhinagar, Gujarat. And in fifth session, we have Dr. Utpal Kumar Shah, Assistant Professor, Basic and Applied Science, NIT Arunachal Pradesh. And sixth session, we have Dr. Mahadevan Chandramaulishwaran, Sri Ramana's College of Arts and Science for Women, Arupukottai. And they are the people, the chairpersons are with us. Participants, please ensure your session, and you can join your session as be scheduled. Any queries, please call us. I'll put our numbers in the chat box. Thank you. Now
the distinguished speakers are free to move any chamber, any session 1 to session 6. If they want to observe the paper presentation session, they may enter in any session. So it's welcome that we are welcoming you to join. And if you are tired, so we would like to advise you to take a rest, have a cup of tea, right? Virtually we can offer snacks and tea, but if you are tired, so take rest, it is better. Because as Dr. Tan told that the mathematical bombardment, really it is extraordinary. He is a mathematics fellow, he is a mathematics fellow. So you are free to visit any session, and you may have a look on the paper presentation that is being carried out.
Yes,
and it is mandatory for all the paper presenters for their assigned session, because tomorrow we have another big session is there for the paper presentation. So no opportunity will be given for the next one. If somebody is missing, it is not possible to engage them in the tomorrow session that is overloaded. Okay,
yes.
Amutha, please.
Yes, sir. Respected chairperson, please report whether you are available. Dr. Mahadevan Chandramaulishwaran.
Mahadevan sir, Chandramauli
join in the link. It's not available in the.
Mahadevan is not. Mauli sir is not there.
Yes, sir.
Okay, let me talk. Amutha
So
madam is here.
Yes, sir. Yes, sir.
Amutha madam is here. Okay.
Yes, sir.
Okay.
Yes, sir.
Okay, Brijesh is here. Brijesh Jha, SD Purohit sir is here, and UK Saha is here. Meenakshi is here. Okay, in the meantime, I'm just calling Dr. Mahadev Chandrababu.
Yes, sir. Now we'll have a short tea break. Please stay on the line. Yeah. After 5 minutes, we resume you. Meanwhile, you can join yourself in a respective session. And participants or listeners can join any of the sessions. And also, we invite our dignitaries can join any of the sessions as you wish. Thank you.
சரி இல்லை எனக்கு இப்போ இது கான்ஃபரன்ஸில் இருக்கிறேன் நான் இப்போ உன்னுடைய இது பார்க்க முடியாது நாளைக்கு பார்ப்பேன்.
the session 6, sir.
Okay. Where to go? You will connect or I?
Yeah, you itself, we connect you, sir.
Okay, fine. Thank you.
Yes.
Sorry for the delay.
And no problem, sir. Respected chairpersons, so you can start your sessions with the instructions given to the participants.
Will there be any moderator for section? Hello.
Sir, so we didn't alert any moderator, so just you itself take care of it, sir.
Okay. Can I have that list of paper presenters for me?
It's available in the.
So, which is available in the website actually.
Website?
Yes, sir.
Hmm.
You can evaluate them and rank them and or grade them as per the presenting, how they are presenting and all.
Okay, okay.
And please submit the evaluation sheet to the organizing committee.
Good evening, ma'am.
Yes, ma'am. Yes, ma'am. Tell me, ma'am.
Ma'am, Navita Sultana, ma'am, paper ID 40. How to join, ma'am? Section 1, ma'am.
And what's her name?
Navita Sultana, ma'am, paper ID 40, ma'am. Session 1, ma'am.
Navita.
ID 40, Navita Sultana, ma'am.
Ma'am, join பண்ணிட்டேன். check பண்ணுங்க. Ma'am, please check Dr. Utpal Kumar Shah. Utpal Kumar Shah. Sir, join பண்ணிருக்கேன் online.
Ma'am, will I be directed to join somewhere else, ma'am?
So what's your name?
Ma'am, ID number 40, Navita Sultana, ma'am. Just now I asked for, ma'am.
Navita Sultana. So
Yes,
in what name you join, my sir? Which is not in the
ID colon 40, Navita Sultana. As it is directed in the mail, I have written ID 40, Navita Sultana, ma'am.
Okay, we'll check. We'll check.
Yes, ma'am.
I am Dr. UK Shaha, Utpal Kumar Shaha. So
yes, sir.
I am the chairperson of the session 5. So
yes, sir. Yes, sir. We'll assign you, sir. We'll assign you, sir. Please
okay,
wait,
okay.
Excuse
okay,
me, ma'am.
thank you.
Hello.
Excuse me, ma'am.
Hello.
Yes.
Yes, ma'am. I'm Soumya Sinha, and my presentation is scheduled after 5 minutes. Can you please tell me when I'll be allowed to give my presentation?
Where you're actually? Are you in the sessions?
Yes, ma'am. I was in the session, and my presentation is being scheduled today. You can
Yes,
please
yes.
ask to Brijesh sir also. He has also said.
See if it is allotted.
Ma'am, can you please tell me?
Yeah, your number.
Ma'am, my submission number was 93.
93 and tell me your name. 93.
Yeah.
Please check 93.
Soumya Sinha. Soumya
Soumya
Sinha.
Sinha, I think your name is not allotted to these chairpersons. Soumya
Sir,
Sinha.
sir, Brijesh sir has already said.
No. Your session definitely you are late late submission. So hopefully your name is not the today's, your name will be tomorrow's. Have you checked your name in the paper
Okay,
presentation?
actually
No, no.
yes, sir. Yes, sir, I have checked. It was written, just my name was written and my topic was written. But
Your
the
name-
number has not been allotted till now.
But your name is mentioned in any session?
No, sir.
No, so
Brijesh
tomorrow.
sir has already.
Tomorrow. You will
Sir, at
search
what
your name
time? Can you
tomorrow.
please tell me?
You visit
Can
the
you please tell me?
conference. You visit the conference website. Every detail will be uploaded there.
Sir, there the number is.
Sir.
December 23. Your assignment will be for December 23. You have submitted very late. So it is not possible to accommodate you today. Tomorrow you will be accommodated.
Ma'am, please, ma'am, இங்க கேக்குறது number 40
This is Menaka, ma'am. Ma'am?
Yes.
Ma'am, this is Menaka. My ID is 39.
Yes. Amuda ma'am.
Yes, ma'am.
Yes, I am in the session 5.
Ma'am, please mention your name.
I am Ananda Selvam.
Yes, ma'am. Yes, ma'am. Tell me, ma'am. We
I
are
am
sending
in
you.
session 5.
Yes, we are sending you, ma'am.
Yes, I have already one session.
Shah.
Opal.
Dr. Utpal Kumar Shah. Your chairperson
Okay.
is in the session.
Okay, I am in that session also.
Yes, okay.
I have another paper.
Yes. We know, ma'am. So you
Okay.
present that you can shift it to the next session.
Okay, ma'am. Thank you.
Amuda ma'am.
Yes,
Amuda ma'am, good evening. I am Yuvarani. I was not still allotted to the session 2.
We are trying it, ma'am. We are trying.
Okay, ma'am. Okay.
Ma'am,
I'm
this is,
Sam to you, ma'am.
I'm allotted to session 1. I could not able to get into session 1, ma'am.
சார் இன்னும் ஜாயின் பண்ணலையா?
அவர் மெயின் ஹால்ல இருக்காரு. வெளியில போயிட்டு ஜாயின் பண்ணுங்க சார் உங்களை.
Dr. Utpal Kumar Shah. Sir?
Yes.
Yes, sir. So, sir, please reconnect, rejoin to the link, sir, because we couldn't assign you to the session. Please rejoin. Come out and rejoin.
Okay.
Thank you.
Okay.
Ma'am?
Yes.
Ma'am, my paper ID is 24, ma'am. My belongs to second section.
24.
Ma'am, my paper ID is 34.
See in what name you are entering that. Please mention that.
Veera Muni, madam. Veera Muni.
Good evening, madam. Ma'am.
Yes. Wait.
My paper ID is 13.
13.
I allotted in
Somi
second
Koleka.
section. Yeah. Yes.
Ma'am,
ma'am.
இவங்கள allot பண்ணிட்டீங்களா? We have allotted, ma'am, session 2.
Okay, I have rejoined.
How to join in
Have you
session 2?
moved, sir? Utpal Kumar sir, have you
Yes,
in the session 5?
Yeah.
Yes, sir. Then you can start your session, sir.
Madam, section 2, madam.
Respected chairpersons, you can start doing your duty. You can start evaluating the presentation.
Ma'am, this is Menaka, paper ID 39, ma'am. Ma'am? Hello, ma'am.
சொல்லிட்டேன்.
Madhura ma'am.
Yes, ma'am.
Session 5 is not started. Not yet started.
Dr. Utpal Kumar Shah is there.
He has left, ma'am.
Amuda ma'am.
Yes,
Section
sir.
number 2. M. Veera Muni, madam. Section number 2. ID number 34.
Right. ஏன் எல்லாம் வெளில வந்து போறாங்க? சார் நீங்க ரீஜாயின் பண்ணுங்க சார், வீரமணி சார்.
Okay, madam. Okay, madam. Okay, madam. Okay, madam.
Hello, ma'am. This is Gracie, paper ID 69. I want to join session 4, ma'am.
Okay.
I'm Gracie.
Gracie.
Hello.
Paper ID 69. I want to join session 4. Session 4, ma'am.
Ma'am?
Ma'am, ID number 40, ma'am. I have not yet been connected, ma'am.
Hello.
Ma'am?
Hello. Amata ma'am.
Hello.
Shall I start the
Session
session?
5ல chair person இல்ல. அமுதா வந்துட்டாங்க. டாக்டர் அமுதான் இன்னொரு இருக்காங்கல்ல அவங்க இருந்தாங்க. யூகே குமார்னு ஒருத்தர் சொன்னாங்க.
Dr. S. Amuda. Ma'am, you are in the main session. You have to go to session 6, ma'am.
Session 3.
Kindly guide me to enter. Ma'am, you have to go to session 3, ma'am. But you are in the main session. Main part.
Okay, ma'am.
Ma'am?
Ma'am?
Yes, ma'am. Yes, ma'am.
Are you able
Ma'am,
to
my
join?
paper ID is 24, ma'am. Rajendra Subha, paper ID is 24.
Dr. S. Amuda.
Madam.
How to join? Excuse
Ma'am,
me, ma'am.
you just rejoin, ma'am. We will again assign you to class session 3.
Okay, ma'am. Okay.
Okay, ma'am.
Ma'am?
Ma'am, ID number 34.
What's your name, sir?
Veeramuni, madam. Section number 2.
Sir, we have joined, but it shows you have not yet joined. You just rejoin. You rejoin the session, we will again join.
Read the meeting, then join it. Join in that. Then
Ma'am, I am Dr. Signature, ma'am. ID number 45. My
Ma'am,
another session is 5, ma'am.
paper ID 13. How to join in session 2?
Then click and join.
What's your name?
Swami Kolita. Paper ID 13.
Which session? Session 2.
Yes, session 2.
Ma'am, I am Vignesh.
நானும் 5ல தான் இருக்கேன். நான் ஏஎஸ் வருதா? உங்க பேர்ல எனக்கு வரலையே.
பாருங்க. Session 2 காமிப்பா. Session 2ல அவங்க இல்ல வந்துட்டாங்க. சோமி கொல்லிட்டா வந்து.
இது ஸ்டார்ட் பண்ணிட்டாங்க.
சோமி கொல்லிட்டா, you have joined.
Hello.
அவங்க பிரேக் அவுட் ரூம் போயிருக்காங்க. இப்போ மெயின்ல இருக்கறவங்க மட்டும் மாத்திடு.
Ma'am, I am Vignesh, paper D5, ma'am.
Dr. S. Amuda, அவங்கள section 3.
Yes, ma'am.
Assignment.
Vignesh, wait, sir. Will assign you.
Okay, okay. Thank you.
விக்னேஷ் நம்ம இதுல தான் இருக்கு. கேளு விக்னேஷ் எந்த செஷன்
ஜாயின் பண்ணிட்டேன்.
விக்னேஷ் செஷன் 5.
Ma'am, my paper ID is 24, ma'am. Rajendra Subha.
Wait, please.
Wait.
Rajendra Subha. In what name you have joined here? Rajendra Subha?
Yes, ma'am.
In what name you have joined?
Singam triple S.
Singam triple S.
You have joined in. How can we identify, ma'am? What is this? Already we have given and instructed in the mail. How can we identify if you put a name like that?
Ma'am, your name is put up. What is your name, ma'am?
I'm Rajendra Subha.
Yes, ma'am. To which session you belong to?
Second section.
Okay, we are moving you. Please join session 2.
Okay,
You
ma'am.
have to rename yourself, ma'am. It shows
Okay,
like
ma'am.
GV.
Okay.
Menaga. Session 5 join பண்ணிருக்கேன். Session 5 ல
Ma'am, Vignesh on session 5, ma'am.
Hello, ma'am. Ma'am, this is Gracie, paper ID 69. I want to
Gracie.
join session
Kathleen
4.
Gracie.
No. Gracie.
Gracie A.
Paper ID 69. I want to
Which session?
join session 4.
Okay,
Section
okay,
4.
sure.
4.
Hello? அப்படியா ஓ
Gracie A. 4. Ask for help. Join கொடுப்பா.
Change. So this is for pre-ictal. When before the seizure occurs, the signals we call it as pre-ictal, and during the occurrence of seizure we call it as ictal signals. So two types of signals can be available. So one is before the seizure occurs, there will be some small pulses. There will be some small pulses. So these pulses will be 1 minute, ma'am. These pulses will actually tell us whether the seizure will occur, say for certain patients. When the seizure, before the seizure occurs, they will have some giddiness, they will have some strange feelings. So when you take their EEG, they will have a regular pre-ictal pulsations. Okay, next is ictal. So ictal signals will be, so they will be having in some cases they won't be having any prior changes, so we cannot predict whether they are going to have a seizure or not. So we can take these EEG waveforms and we can analyze them.
Please tell your name, in what name you joined.
I'm Rajendra Subha 24 ID.
Is it in that name? 24 Rajendra Subha, is it in that name?
Yes, ma'am.
In this session, which sessions you are belongs to?
Second section.
Two. Yes, we assigned you. Please go ahead.
Ma'am, I'm Vignesh.
Rajendra Subha, please go ahead.
Ma'am,
Yes,
I'm
the next.
Vigneshwaran, ma'am. Paper ID
Sir,
45.
Vigneshwaran sir, we assigned already. Vigneshwaran sir, paranga. Vigneshwaran sir. Sir, in this session, sir.
5,
Vigneshwaran
ma'am.
sir.
5, ma'am.
5. Vigneshwaran sir, 5 assign பண்ணு. Sir, Vigneshwaran sir, நாங்க assign பண்ணிட்டோம், பட் உங்களுக்கு நீங்க தான் ஜாயின் பண்ணல, அதனால நீங்க வெளிய போயிட்டு நீங்க திரும்ப ஜாயின் பண்ணுங்க.
சரி ma'am. Okay ma'am. Thank you ma'am.
Amada ma'am?
Yes sir. Yes ma'am.
I have joined in session 5.
Ma'am, we not yet started, ma'am. Yes, mama. Another hello, mama.
Ma'am? Ma'am? Hello, ma'am? Can you hear me, ma'am? Hello, ma'am? Ma'am?
Yes,
Hello, ma'am. Ma'am, I'm Gracie. Yet now I didn't join session 4. So
Ma'am, we
please
assigned
join.
already. Assigned you, ma'am. Gracie.
But ma'am, yeah, Gracie.
Session,
But
ma'am.
session 4, ma'am.
Session 4. Session 4.
Yeah.
Gracie A.
Yes.
We assigned you.
But
Session 4. Assigned you, ma'am. Please check whether you are in the session 4.
Automatic, say Raspberry Pi or any other processor, it will be able to automatically classify whether it is seizure or not. So when you see for normal signals, it was the coefficient packet was from 200, but here it is in the range of some thousands, the histogram in of some thousands. So the work that was actually done here for this is the histogram of this color image is taken. Then k-means clustering is taken for grouping the shades to equal divisions. Then we are calculating what are the primary colors present in each shade, and the percentage of colors present in each image is taken, and the percentage of cyan blue, this is a cyan color, cyan blue and all other shades, they will give us the idea of what are the frequency present. So see, for each color, so using k-mean clustering, the whole image has been divided color wise, equally divided, because the colors takes up values from 0 to 2
of X with the help of the lower approximation and upper approximation boundary approximation. We have defined tau R of X as U empty set and singleton Q P. The set consists of PV and set consists of PVQ. And we have taken B as the impact of online teaching on students as ITSE, be the universe on students' characteristics, with V by R dash is equal to the set consisting of IS and TC. And Y the non-empty set T comma S. Now the topology tau R dash is given as V empty set and TC. So we define the function f from U to V by f of p equal to c, f of v equal to c, and f of m equal to I, and f of q equal to t, and f of g equal to s. Then the inverse image of every nano alpha open set in B is nano.
First row, one can have 10 plus 10 plus 12 plus 11 plus 13. That is what we have. So what we can have, say 10 plus 10 plus 10 plus 10 plus 10, that is 50, 53, 54, and 56 plus 2. That's so 56 modulo 5 and so on. So 56 modulo 5 in the first penalty column, we are getting 1. Okay. and apply the same northwest corner method, or not the northwest corner method. Apply the same problem for the column also. See the second row also, take the addition, take the modulo over 5. Third row, take the addition, take the modulo 5. So we get the first penalty column 1, 2, 4. And for the row below the demand, apply the addition of the columns and go for the modulo 5. So we get the 3, 2, 2, 0, and so on, and apply the same thing. Now out of this first penalties 1, 2, 4, 3, 2, 2, 0, the 0 is the minimum.
S is subset of X. S is equal to union of A, union intersection of BI. Satisfy the following three axioms. Empty X belongs to N2, and union arbitrary union is belongs to N2, and finite intersection belongs to N2. So the space X, N2 is called N topological space. So these are the basic theorems in N topological space. In N topological space, every semi-open a set is a subset is a semi-open if A is subset of N2 closure of N2 integer of A, and a subset is a N2 beta open if A is subset of N2 closure of N2 integer of N2 closure of A, and a subset B is said to be B open. A is said to be B open if A is subset of N2 integer of N2 closure of A union N2 closure of.
Fluid with heat and mass transfer moving is very important. Infinite length with time-dependent suction, considering the presence of heat source. So here, due to the semi-infinite plate surface assumption, all the flows variables except the present introduced the functions of y and at the time only. A constant transverse magnetic field is applied in the direction of y-axis. So these are all the assumption in my present work. So now I will directly go to that the equations. Here I have taken that first equation as the continuity equation, that is dou v by dou y is equal to 0. The second one is the moment equation. In the moment equation for the first part of the right hand side due to presence of the magnetic field, again the second one occur due to the Gaussian field. The third part of the right hand side equation is buoyancy force. The third equation is represent the energy equation. The right hand side of the third equation represent heat source term, where K is the thermal conductivity, and the last term, that is dm, represent the diffusion thermoterm. The last equation, that is dou phi by dou T, is species diffusion equation, where capital D is the mass conductivity. Here the second term of the right hand side is the chemical reaction term. Here I have used in the first order.
Good afternoon, dignitaries. Good afternoon, dignitaries.
Now this is the boundary condition for that equation 1, 2, 3,
Good
4.
afternoon, dignitaries.
So now
Good afternoon, dignitaries and
this is the continuity. This is the plate is in the normal position is updated to the variable section and form the equation of continuities. V star is equal to minus V naught. So from the equation 1, in equation 1 we have dou V by dou Y is equal to 0. So which V is a constant, or we can say the function of T. So I can get V star is equal to minus V naught plus 1 plus epsilon alpha e power delta T. Here I am going to introduce some non-dimensional scheme. So non-dimensional scheme from the, and after I introduce the non-dimensional.
Yeah. Sir, my paper name is differential topology on manifolds with boundary, sir. As well as my name is G.V. Shanmugapriya, Assistant Professor, Department of Mathematics, the American College of Madrid, and my paper ID is 53, sir. Sir, I am doing my PhD under the guidance of Dr. Dominic Christopher, the Principal and the Secretary of the American College. These are the.
Okay.
Sir, in this paper, the manifolds with the in differential topology, how manifolds with boundary are explored. The standard material in this paper, I explained the standard material and the mention of manifolds with the boundary and some dimensions and examples. And at last I explained briefly the Breuer fixed point theorem and its needle lemma, sir. Just first I explained the definitions. Manifolds with the boundary, fix a positive integer m and introduce the notations. That is h power m equal to set of x equal to x1 x of etc. xm belongs to that r power m such that x greater than or equal to 0. Then that is the partial differential of h power m is equal to set of x equal to x1 x of etc. xm belongs to r power m such that x equal to 0 for the m dimensional upper half space and its boundary. Then definition, first definition I explain, a smooth m-dimensional manifold with the boundary consists of a topological space M and open cover U alpha. Alpha belongs to A of capital M and a collection of homeomorphism pi alpha from U alpha to psi alpha onto open subset psi alpha containing h power M. And for every alpha belongs to capital A, such that for every pair alpha comma beta belongs to capital A, and the transition map, now we define the transition map, pi beta alpha equal to pi beta composite pi inverse of alpha from pi alpha of u alpha intersection u beta to pi beta of u alpha intersection u beta is a diffeomorphism. The next definition is the homeomorphism pi alpha from u alpha to psi alpha are called charts, and the collection
sir.
Yes, madam. Session 3, myself and
okay, sir. Session
Dr.
3.
Angappan name is another name is there.
Yes, sir. Yes, sir. I'll ask you.
Yeah, okay.
Sir.
Yes, madam.
Session 1, session 3.
Session 3.
Session
3, madam.
We assigned you, sir. Now we are in. We joined, sir. Session 3.
Session 3, madam.
Have we joined, sir?
No, madam.
Sir, just rejoined it, sir. Actually, there is a list. Please rejoin.
Oh, okay.
Oh. Join. Anbalagan, sir. Sir. Anbalagan, sir, we assigned you. Are you in session 3?
Dr. Mutha, everything is fine?
Yes, sir. Going on well.
Okay, all the presenters are present.
They are presenting, sir.
Still some absentees are there.
Sir?
Some absentees are still there, as all are present.
So few absentees are there, sir.
2 absents are there. So be careful that there may be persons, some persons may try to enter any one of the room without any ID number.
Yes, sir. Yes.
Yeah. Just now you
So we
recall.
have a copy. We checked it, and then only we
Yes.
had.
Okay, fine. So yesterday, tomorrow, just tell me, Amutha. Tomorrow the 3 session is enough, or we will have to increase 1 or 2 more session?
We have to verify the number of people, sir, and I gave Mandal to the absentees. I gave to Mandal. Actually, the absentees over, I think, eight of them absent yesterday.
Okay. And tomorrow 3 sessions are there.
Okay, sir.
2 sessions is for.
We'll make them to fit into the session, sir.
Okay, try. Sure. Go ahead.
return back. But in online, there is some thing where we browse the online portals, let it be Amazon, let it be a Flipkart. They do browse it twice a day, or almost often whenever they find time. So what would happen is, suppose if I see a product but I don't have a money at the time, so I put it in the car, I put it in the wish list. So next time again I look into the particular online portal, what will happen is it will pop up in the first slide telling that these are the products available in this serve the customer, and with that they will and thank you.
Okay, so we are thankful to Somi Kolita. First of all, I am personally thank you for giving a nice presentation, and through your presentation, I feel that mathematics is useful in the language also.
Thank you, sir.
However, I am just hearing that mathematics is a part of language as well as science. So firstly, I am seeing that mathematics is useful in the literature as well as in the language also.
Thank you, sir.
Yeah. So any other participant who want to ask some question? Okay, so no questions from other side and my side also. Now I invite Dr. K. Rajendra, paper ID is 24 for his presentation. Are you there?
Yes, sir, I'm here.
Okay, okay.
Shall I share my screen, sir?
Yeah, you can share your screen.
Is my screen visible, sir? Sir?
Yes, your screen is visible. You can go ahead. Yeah.
Okay, sir. Yes, good evening all. I am Rajendra Subha, full-term research scholar under the guidance of Dr. Anbarasi Rodrigo, St. Mary's College, Autonomous, Thuthukudi, Tamil Nadu. So here is my presentation. That is, my topic is functions with soft ARS closets in soft topological spaces. So I started with my definition. That is, here is my abstract. So in this paper, we have introduced soft ARS homeomorphism and saw strongly soft ARS homeomorphism in soft topological spaces. And we have obtained some of the properties, and we have given some characterization of these two functions, and we have obtained some counter examples also. And these are the soft sets which I have used in this paper. I have mentioned here. So here is my definition. That is soft ARS homeomorphism. So a function is said to be a soft ARS homeomorphism if it is both soft ARS continuous and soft ARS open. So I have given the definition for soft ARS continuous here, and soft ARS open map is also. So followed by that, I have given an example. That is, I have proved that I have chosen tau complement, that is an open set and a closed set, and I have obtained soft ARS closed set also, and I have sigma and sigma complement and soft ARS open also. And I have proved that this function f is soft ARS continuous and soft ARS open. So altogether I can combine and say that the function I have defined is soft ARS homeomorphism. And moving on to the next one, and we have obtained few more theorems. That is a characterization of soft ARS homeomorphism. That is the first result we obtain here is every soft homeomorphism is soft ARS homeomorphism. For that I have given a proof for that. But coming to the converse part, that is every for is a soft ARS homeomorphism is soft homeomorphism means the converse is not true. So for that I have given an example here. So in the example, the function is soft ARS homeomorphism, but here it is not an open map. Here it is a soft ARS homeomorphism, but it is not. We have proved that it is not soft homeomorphism because it is not soft continuous. So we have proved that the converse is not true here. So likewise, the same thing we have obtained few more properties that every soft homeomorphism, every soft alpha homeomorphism, and every soft semi-homeomorphism, and every soft JP homeomorphism is soft ARS homeomorphism. But the converse is not true. For each and everything, I have given an example for that. And also we have obtained that every soft ARS homeomorphism is soft GSP homeomorphism. But the converse, that is a soft GSP homeomorphism, is not soft ARS homeomorphism. So from this, I can conclude that my set, that is soft ARS homeomorphism, lies between soft semi-homeomorphism and soft GSP homeomorphism. And let us move on to the next case, that is an independent cases. After finding the properties and the characterization, I have find out the independent for my set. That is soft ARS. That is soft ARS homeomorphism is independent to soft pre-homeomorphism and soft G homeomorphism and beta homeomorphism, omega homeomorphism, alpha generalized homeomorphism, and GS homeomorphism. And finally, it is also an independent with soft strongly G homeomorphism. And the next topic is strongly soft ARS homeomorphism. So I have defined that the function is said to be strongly soft ARS homeomorphism if F and its inverse are soft ARS irresolute. I have given an example here. And interconnection, while I am first thing I have introduced soft ARS homeomorphism and next soft strong ARS homeomorphism. Now I am having the interconnection between these two definitions, that is every strongly soft ARS homeomorphism is soft ARS homeomorphism, but the converse is not true. For that I have given a counter example. In the same case, as every strongly soft ARS homeomorphism is soft ARS irresolute, but the converse is again not true here. So for the converse part, I have given the example here. And coming to the composition. So already we know that composition of any two function is again that is a composition of two continuous function is again a continuous. But while I move on to this set, that is my set, that is soft ARS. While I am taking the composition of soft ARS homeomorphism, that is not true. I'm still working on to find out the case, the missing case, to make it as a soft ARS homeomorphism. That is a composition is also true. I'm still working on it to find out, but still I am not able to find out. So I have proved that it is not, the composition is not true here. So for that I have given a counter example here. But moving on to the strongly soft ARS homeomorphism, the composition is true here. So I have given the theoretical proof here. So these are my definitions about soft ARS and strongly soft ARS homeomorphism. And these are all my references which are required to complete this paper. Thank you. Thank you for your patience listening. Thank you so much.
Okay, sir, we are thankful to you for your nice presentation. Any questions from other presenter side? Okay. So now I call Mr. Avinash, paper ID
Good
28.
evening, sir.
Yeah, good evening. You can share your PPT and
Shall I share my screen?
Yeah, you can share your screen.
Okay, sir. Is my screen visible?
Not yet. Your screen is not visible yet.
Sir?
Yeah, now it is visible.
Oh, okay, sir.
Yeah.
Okay, good evening, everyone. My name is Avinash. I am a faculty and part-time research scholar of Department of Mathematics at Sagadat College, Tirupattur, Tamil Nadu. Okay, my title is a new kind of encryption and decryption of RCP color image using permutation matrix multiplication. So actually, this problem comes under theory of cryptography. So this is my abstract, and in this paper, I'm going to encrypt RGB color image with the help of a double coding a permutation matrix. That means one is pre-multiplying, one is post-multiplying. I'm just encrypting the digital content of RGB image into the encrypted form, and I will explain also the decryption process using the help of matrix again. And also I'm introducing two new definitions. One is block, another one is k-portate block. And there are many algorithms regarding to this is available on the net, and this is quite different from it. And let us start with the word permutation matrix. Okay, permutation matrix is a square matrix as the binary matrix. Binary means consisting of 0 and 1, that has exactly one entry of 1 in each row and each column and 0 elsewhere. So simply speaking, the permutation matrix is obtained from the identity matrix by using the elementary operation interchange of rows, interchange of columns, or a sequence of application of interchange of rows. We can produce a permutation matrix from an identity matrix. And here I am showing the possible permutation matrices of 3 by 3. The first one is 1 0 0 0 1 0 0 0 1. It's a familiar matrix simply denoted by I. It's identity matrix. And the next matrix E1, you may observe that in each row and each column there is exactly one and the remaining entries are 0. So there are I, E1, E2, E3, E4, E5, totally 6 permutation matrices of order 3 by 3. And if you are looking for the order 4 by 4, that's exactly 24 permutation matrices for 4 by 4. If you go for order 5 by 5, square matrix of order 5, there's a 5 factorial, 120 permutation matrices are there. Okay. So, and you may observe that each permutation matrix is obtained from the identity matrix. So it evidently, by the interchanging of rows and columns, that means they are equivalent matrices. So this evidently shows that all the permutation matrices are invertible. Okay, and one more observation, and this set of, suppose we are looking for the permutation matrices for 3 by 3, there are 6 matrices, and take the operation matrix multiplication, and this forms a group under matrix multiplication. The set of matrices I, E1, E2, E3, 4, E5 form a group under matrix multiplication. It is a non-abelian group, and especially this group is isomorphic to S3, that is symmetric group on 3 symbols. And this is applicable for higher orders. If you are looking for a 4 by 4 permutation matrices and take the operation matrix multiplication, and it's evidently it is isomorphic to S4 and so on. Then here we are going to encrypt the RGB image. So I am giving just some informations about RGB color image. So R for red, G for green, B for blue. So here red, green, blue are primary colors. The combination of these colors is another color. Then we may note that there are some colors which are out of this RGB system, but I am considering only the RGB color images only. Okay, and this diagram shows that the possible combination of red, green, blue, and if you are mixing blue and green, you may get a cyan, and blue or red, so you get magenta, and yellow and white. So with some way. Then if you're taking the red color, so there are many light red, so dark red. So there are many varieties of red. That is called intensity of color. And each intensity value is between 0 and 255. So discrete value 0, 1, 2, 3, 4 up to 255. There are 256 levels of each intensity. And so this RGB color image, so we need to talk about the input devices and output devices for this. So the main purpose of RGB color model is for sensing the representation and display of images in the electronic systems, such as televisions and computers, though it has also been used in the conventional photography. And the typical RGB input devices are color TV and video cameras, image scanners, and digital cameras. And RGB output devices are TV, sets of various technologies like CRT, LCD, plasma, OLED, projector like. So there are projectors, and computer and mobile phone displays, video projectors, multicolor LED displays, and a large screen such as Jumbotron. So all they are only the electronic items. So if you are doing this encryption, we need an electronic equipment like the screen and the color identifier and the color picker tools. And now I'm introducing the new word with matrix and the encryption technique. Okay, so first look at the RGB color channel. So I already told that there are 256 levels for the intensity of each color. So RGB means the combination of 3 colors is produce a new color. So each has 256 possibilities. So X, Y, Z. The first for R components, the second for green component, third for blue component, and the both values are lying in the set 0 to 255. So but the permutation technique, combination technique, we have 256 times 256 times 256. That is 256 cube colors, different colors in the RGB channel. So totally 16,77216 colors are there. And I told that there are some colors which are falling out of colors. Okay, we don't bother about that. We are looking for the RGB color images only. And take any 3 colors for better understanding. I'm choosing C1, color 1, color 2, color 3, X1, Y1, Z1, X2, Y2, Z2, X3, Z3. And I'm forming the pixelate matrix. Okay, so pixelated matrix representation is C1, comma C2, comma C3 is equal to is a 3 by 3 matrix because the first row stands for the first color X1, Y1, Z1, second is X2, Y2, Z because Z2 is second one and C3 is the third one. So its component are coming in the third row X3, Y3 is Z3. You may observe that the first column for the red component, the second column for the green component, third column for the blue component. If you are adding another color C4 here, and you get a new row X4, Y4, Z4, and okay, anyhow, this is a matrix of order 3 by 3. And if you're taking three colors, and there are another possibilities. So here, look at the note. There are 6 pixelate matrices for the 3 fixed colors. So just to change the order, just permute C1, C2, C3. If you are getting C1, C2, C3, or look at the second one, C1, C3, C2, that means it just the second and third row are interchanged here. It is a new matrix. In the sense of a matrix, they are different, right? So there are only 6 different pixelate matrices can be produced from 3 fixed colors. Okay, then the encrypted technique. Now I explain how to encrypt this matrix. And already I talked about the permutation matrices. Pixelate matrix is encrypted as X times P times Y, multiplied by X and the post multiplied by Y, where X and Y are permutation matrices or 3 by 3. Okay, so okay, there are two matrices. It's our choices on arbitrary choices. If you are looking for order 3 by 3, there are 6 permutation matrices are there. So there are 6 possibility for X and 6 possibility for Y. You can select any one of the permutation matrices for encryption. And suppose this XPY value is a 3 by 3. So matrices A, B, C, D, E, F, G, H, I. This is an encrypted matrix. This is called encrypted matrix. So now the original is X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3, in which the first row represents the first color C1, and this is the new matrix. The first row is ABC. So the first one, X1, Y1, Z1, mapped it to ABC. And you may observe that these A, B, C, D, E, F, G, H, I are the values of X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3, because we're just permuting only. We never produce any other integers. Okay. So anyhow, C1 goes to ABC and C2 goes to DEF, C3 goes to GHI. Similarly, we can assigning a color for each color. Okay, this is an encryption. This is an idea behind the encryption. And I'm introducing the other definition, portite and k-portite blocks. So portite, this word comes from the partition. I will explain why this name comes. And we are familiar with the word pixel. A pixel is generally thought as the smallest single component of a digital image. Okay, let F be a collection of all pixels in an image. Okay, take any image, but particularly RGB image, a collection of all pixels considered as F. Suppose there are n pixels. I'm choosing a C1, C2, Cn. C1 stands for first pixel, C2 stands for second pixel, and Cn stands for nth pixel. And in addition, the first pixel color is represented as the same notation C1 for better understanding. Okay, F be the pixel set. I'm introducing the definition block, that is portrait block. I'm DI with the subsets of a pixel set F. I'm taking some subsets from F. Then now the qualifications of DI are that each one is non-empty and mutually disjoint, and whose union is equal to F. This is exactly the definition of partition of a certain analysis. Yes, that is the thing. And these DIs are called as blocks, and in particular, portrait blocks. Because the partition, I'm just taking the word portrait from the word partition. Then k portrait block. So k is an integer which is running over 1, 2, 3, n, where n is the total number of pixels in an image. Then k portrait block is a portrait block which containing k partitions, because you may break up into F into two sets, or into 3 sets, or into 4 sets, into 5 sets, up to n sets. The size is yours. So this particular number is called a k portrait block. And ordered block means you are giving some order, so arranging elements in the particular order. So that is called ordered blocks. So now considering RGB image with 9 pixels. So for a better understanding, okay, that means there's an image with 9 pixels. Okay, so I just draw the diagram. C1, C2, C3, C4, C5,
Dr.
C6.
Avinash, we
Like
have
that.
to take care about the time.
Okay, sir.
Yeah.
Okay, just 2 minutes, sir. And I'm just cutting a two-parted block. Okay, I'm just grouping two elements. So here C1, C4, C7, and C2. The remaining colors are dropped into here. So you may drop like here are 4 elements. There are 5 elements. Choice is yours. And now I'm giving the specific order C4, C1, C7. I'm producing the matrix as P. Is one of the possible pixelate matrix for C. So here also I'm giving the another possible order for second one. So anyhow, 2 pixelate matrices, and I'm encrypting each matrices with the help of permutation matrices, double coding key. So APB and CQD, ABD are permutation matrices of order 3 by 3. Since D is then a pre-operator, so the post operator. So C is a permutation matrix of order 6 by 6. So we can give any order to event blocks, and choice of selection permutation is arbitrary. Okay, now I derive the encryption of each potted block of 10 pixels image. Uh, so for a one potted block, I'm getting this huge number 7900 something, and for two potted block, there are this number of encryptions, and 4, 5, 6, and go on up to 9. I'm getting this. So totally 10, 175, 248, 000, 000. So nearly 10 trillion plus.
Next slide, please. Finding of my study, CSR communication strategy of the company. The difference were found between sustainability report and the stakeholder opinion on the internet shows that companies are not communicating the CSR practices in the efficient way. Our research helped the company to find out whether the CSR communication is where the CSR communication is failing. Our proposed model of using CSR IRS-IS method used to find the feedback of the stakeholder and can improve the gap of the company where they are failing. If the company engaged more in the social media update and being transparent, it will gain more trust and awareness among the stakeholder that can improve the reputation of the company. Last slide, please. Then finally, we are coming to conclusion and limitation. Conclusion, there is an increase in the number of CSR tweets when the CSR report is published by the company. Then CSR tweets posted by the stakeholders are used to inform more than provided opinions. They use those as information more than they're giving opinions. For example, like when they want to invest in companies, they use tweets as information, the stakeholders. There is a gap between CSR report and the stakeholder opinion about the company. This could be because of lack of adopted, and it's going to be developed, and I'm in the process of developing that method for the analysis of sentiment of contents of tweeters. Thank you, ma'am.
Okay, so do you have any idea how the sentiment analysis is done?
Yes, ma'am. It's done in the R program.
No, it can be done in other platforms also. It is not only that R, it is not that we can only perform the sentiment analysis in R. So what are the steps you have thought to follow for the sentiment analysis?
Firstly, for answering the first question, there are few software also to do sentimental analysis, but it was the software like CSR Hub was there when I was finding in the internet, but it was asking for the payment. But our program is a little bit, our program is freely available. So I have chosen the R program.
R is there. Okay, Python, you can do sentiment analysis in Python, you can do it in Java, MATLAB is also there. So there are plenty of tools on which you can do sentiment analysis. So what steps do you have planned to follow this sentiment analysis?
Firstly, to collect, observe all the Twitter command during the year of 2019 and 20. Because 18 and 19 study were already done on different companies. So during the year of 18 and 19,
I'm asking the steps. I'm asking the steps. There are few predefined steps for sentiment analysis.
Yes, ma'am. Data collection, data miming, and also then data miming using eliminating all the duplications, symbols by using layer command and using TM command. Then we will evaluate CSM, whether it's positive or negative. If it is positive, one. Ma'am, sorry, like this is the first time I'm working in R. Is there anything I can improve, like follow the sentiment analysis and improve my paper?
Basically, you need to understand some part of text mining.
Okay, ma'am.
Okay, for the sentiment analysis, it is not like that everything will be presented in the form of smileys. There will be some text. No?
Yes,
So you
ma'am.
need to do text mining also.
Yes, ma'am.
So there
Okay,
is
yeah.
stop word removal, and there is something which is called as synonyms finding. So
ma'am.
if you are planning to do the sentiment analysis using any of the social media, then you need to have the basic understanding of text mining also.
Yes, ma'am. Yes, ma'am.
Okay, okay. Thank you. Good.
Thank you so much.
Okay. So anyone left? No. Host, I think all the participants have presented the paper. It was a really a nice session.
Thank you, ma'am.
Thank you, Navita. Hello, who's there from the host?
And this representation E of r comma t is equal to E naught e power minus I k dot r minus omega t is the representation of radiation states in a classical way. But in quantum way, this representation is not valid for non-classical states. A and A dagger that are the quantum mechanical operators. These operators can be defined the non-classical states. So why we should study about the non-classical state means the applications.
Do we have to connect to the main Zoom app? I mean Zoom link?
I think no, everybody has left except you and me. I think so.
Okay. No, I'm asking whether that we are connected with the breakout box, no?
No,
So we have to go to the main box or what?
I don't know, I don't know. Okay, we can leave.
Leave breakout.
The state called coherent state. In reality, coherent state is a laser. So we are theoretically we are considered that classical state, coherent state. So this is the mathematical representation of coherent state. Ket alpha is represented the coherent state. So it's like a stacking of books arranged in this manner. The coherent state is a superposition of number state keten. So if I arrange the keten in this manner, if I remove any one of this book, then this state will be a non-classical state. This state will exhibit the non-classical behavior. So we are constructing that from the coherent state, we are removing multiple number of states from the coherent state, so that this newly constructed non-classical state is called as a multi-number state filtered coherent state. So this is our frame of work. This ket psi represent our state of the system. So now we are going to test whether this state exhibit the non-classical behavior or not. So we are adapting 3 non-classical criteria to check the non-classicality of the constructed quantum state. So the first one is Vogel's criterion. This was introduced by Vogel, and this is the DN matrix. So this criteria says that any one of the 2 cross 2 or 3 cross 3 matrix is determinant of any of the 2 cross 2 or 3 cross 3 matrix is less than 1, then this the state will exhibit the non-classical behavior. So we calculated the expectation values of this matrix, and I have taken the 3 cross 3 first 3 cross 3 matrix, and I have found the determinant. So it reveals the non-classical property. In this figures, you could see that the curves are going to the negative. So this is for single removal state. This is for multi-number state removal. So the non-classical, our constructed state is exhibit the non-classical property is once again confirmed. Then the second
zero into h power bits. So by this definition, we have to construct this lemma 2, sir. Lemma 2. Then our main theorem is a Breuer fixed point theorem. Every continuous, the statement is every continuous map has a fixed point. Okay, sir. So for this theorem, we have to first prove some of lemmas and chronology. So lemma, the one is every non-empty compact connected smooth one manifold is diffeomorphic either to the unit circle s power 1 is equal to z belongs to c such that mod z equal to 1 or to the unit interval. The closed interval 0, 1 is equal to z equal to t belongs to r such that 0 less than or equal to t less than or equal to 1. Then the next corollary is needed corollary for this Breuer fixed point theorem is Sharp-Brown's theorem sort of corollary. Let n be a smooth n-dimensional manifold. Let n be a smooth n-dimensional manifold. Let us divide a function f from m to n be a smooth map, and let Cf contain capital M be a set of critical points of f. Then the set f of Cf of critical values of f has a level pressure 0 in each coordinate chart, and the set R equal to M such that M by that is F of C of regular value. So F is dense in capital M. Okay, so the next lemma is let M be a middle lemma for this Breuer fixed point theorem is let M be a compact smooth in manifold with boundary. There does not exist a smooth map F from M to dou M that restricts to the identity map on the boundary. Then another one middle lemma is let G from D power M to D power M be a smooth map. Then there exists an element H belongs to D power M such that G of X equal to X. These are the middle lemmas for this Breuer fixed point theorem. This is the well-known theorem, sir. Then proof of this Breuer fixed point theorem is let G from D power M to D power M be a let us assume G from d power m to d power m be a continuous map and assume that g of x is not equal to x or x belongs to d power m. Then since d power m is a compact subset of r power m, there exists a constant epsilon greater than 0 such that model of g of x minus x is greater than equal to 0 for all x belongs to d power m. Then by the Weierstrass approximation theorem, we have to conclude m equal to d power m and that a be the set of polynomials in m variables with the real coefficients. There exists a polynomial map p from d power m to d power m such that modulo p of x minus g of x which is less than epsilon for all x belongs to d power m. Now we have to define a map q from d power m to r power m by q of x equal to p of x by 1 plus epsilon for all x belongs to d power m. The model of q of x is less than or equal to 1 and the model of q of x minus g of x value is model of p of x minus g of x minus epsilon into g of x the whole divided by 1 plus epsilon which is less than or equal to model of p of x minus g of x divided by 1 plus epsilon plus model of epsilon into model of g of x divided by 1 plus epsilon which is a value which is strictly less than 2 epsilon for all x belongs to d power m. Thus we conclude that q then given the map q from d power m to d power m is a smooth map with a fixed point. Okay, so but we have to construct the argument that q the map q has a fixed point, which is a contradiction to our lemma 5. Okay, in lemma 5 we have to conclude that there is an element x belongs to d power m such that g of x is equal to x. Fixed point இருக்குங்கிறது நம்ம சொல்லிருக்கோம். ஆனா இந்த தியரத்துல வந்து இல்லைங்கிற மாதிரி நம்ம கொண்டு வரணும்னா which is a contradiction to our assumptions. So we got to conclude that this is a proof of our theorem. We got to conclude that by Breuer's fixed point theorem, every continuous map has a fixed points. These are the main proof of this theorem. These are my reference for this paper, sir.
Okay, so nice presentation. Only one question. Okay, I think what will happen if your Lebesgue measure is not equal to 0? One condition you have chosen that Lebesgue measure should be 0. Yeah.
Relevant values value வந்து not equal to 0 வரும் சார். Lebesgue measure value வந்து 0 வராது. Each coordinate chart வந்து Lebesgue measure value வந்து not equal to 0 வந்துச்சுன்னா regular value
faculties are there? How many faculties are there in maths department?
In regular faculties, regular department, 13 staff, sir. Okay. With SF staff, 33 staffs are there.
Okay.
Just a minute, sir. Deal. இந்த செஷன் முடிஞ்சிருச்சு, செஷன் 5. இப்போ நான் அப்படியா? அப்புறம் நாங்க
Sir, sir, I hope you have finished this session, sir, isn't it? Professor?
Okay. Yes. Okay, so this session is
With
finished.
this, you can
One
conclude this
participant.
session, Professor.
Okay. Then one presenter is not there. He is absent. Dr. D. Lordo Immaculate is absent. So, should I leave the session?
Okay, Professor, we have noted.
Okay. So, thank you very much for joining this session. So,
Thank you, Professor.
wish you a very bright future. So I'm leaving. So tomorrow morning I will send you the details report.
Okay, Professor, okay. To the organizing committee, you send the reports, Professor.
Okay.
Thank you.
Thank
you. Hello, Professor Chandramoulishwaran, Professor.
Tell me, please.
Hello? Professor, the consolidated report, you can send this to amudajo@gmail.com, mail ID.
You please send me that once again. Amuda.
AMU.
Yeah.
THA.
AMU THA.
JO.
JO.
@gmail.com.
JO. All small letters.
Yeah, Professor.
Okay, thank you.
You send
Thank
the
you.
consolidated report to this mail ID, Professor. Thank you very much for your cooperation. Thank you, Professor.
Okay, thank you. Thank you. Fine.
Yes. Friends, with this, we conclude today's session. We will meet tomorrow at 2 p.m. Professor Aristotle, Shanmugapriya, Swapna, you can leave. We are going to end the meeting. Okay, thank you so much for your cooperation. Thank you.
Thank you, ma'am. Can you leave?
Yes, yes, Professor, you can leave.
Johnson.